Adrian, and I'm here to help you with the ACT and the SAT. And in this video, I just want to give you some questions to do on matrices. And basically the four operations you need to know how to do with matrices are addition, scalar multiplication, multiplying two matrices together, and the determinant of a 2 by 2 matrix. We went through all of these four operations in my previous video. So if you feel unsure about any of these, or you've never come across matrices before, you might want to watch that first. Otherwise, I'm just going to let you loose on these questions and give you 2 questions for each operation and see how you do with those. And if you can do all of these, then you should be absolutely fine with any matrix question the ACT has to throw at you. Okay, so you ready? Let's get started with the first question. Okay, so here are our first 2 questions, and these are matrix addition questions. If you want to pause the video now, please do try and solve these by yourself, and then we'll go through the answers afterwards. Okay, so how did these go? In the first question, we just need to add the corresponding numbers from each matrix. So along the first line, we're going to do 10 plus 6, which is 16. We're going to do minus 5 plus 12, which is 7. We're going to do 15 plus 18, which is 33. And then the second row, we're going to do minus 9 plus minus 10 is minus 19. 3 plus minus 20, which is minus 17. And then 6 plus minus 30, which is minus 24. Now the second question is not quite as straightforward, but we need to think about how this works. And essentially we get a set of simultaneous equations. So if we take the 2 corners that have the a and the b in, we can extract the equation 2a plus b equals 15 from the top right corner. And from the bottom left corner of 2 matrices, we can get 3b plus minus 2a equals minus 3. When we stack these 2 equations above each other, we notice we have a simultaneous equation. We need to work out the value of b. If we add these 2 equations together, the 2 a's cancel out, and we end up with 4b equals 12, and therefore b is going to equal 3. Okay, how did you do? Hope those worked out. Now we're going to move on to the next 2 questions, which are scalar multiplication questions. Again, if you want to pause the video, have a go at these questions yourself, please do that, and then restart. Okay, so how did they go? And again, in the first question, question 3, with scalar multiplication, we just multiply everything inside the matrix by what is outside. So 3x times 10 would give us 30x in the top left. Top right, we're going to have 3x squared. In the bottom left corner, we're going to have 3x squared y. And in the bottom right-hand corner, we're going to have 3x times 4, which is 12x. Next question is going to be a little bit more complicated again, so we need to figure out what y is equal to. The first thing I'll think about is what is x equal to? And if we think about the top left corner, we're going to have x times 5 equals 15. So another way of saying that is 5x equals 15, and therefore x equals 3. So our scalar multiple here, x, is actually just 3. We're multiplying everything in the matrix by 3, and therefore we can think about the bottom right and the bottom left and the top right corner, and we have x times y equals 30. If x is 3, then we know that 3y equals 30, and y is going to have to equal 10. Okay, so let's move on to some matrix multiplication questions. The first one here, question 5, is just asking us if we can or cannot do certain matrix products. So again, pause the video if you want to have a go for this yourself, and then I'm going to go through it afterwards. Okay, so which of these statements did you think was true? And what you want to do here is to compare the number of rows and columns in each matrix. So I would put them next to each other. I would say matrix A is a 2 by 3, matrix B is a 4 by 3. So is the matrix product AB going to work? Well, it's the inside numbers that would have to be the same. And here we have 3 and 4, they're not the same. And so AB is undefined, and therefore statement 1 is not true. For statement 2, we would want to have matrix A and C next to each other, compare their dimensions. We have 2 times 3 for matrix A, 3 times 5 for matrix C. The number in the middle is 3, so that's the same, so that this matrix is going to be defined. But what's the resulting dimensions? That's going to be the outside numbers, and that should really be 2 by 5, not a 3 by 3. And so statement 2, although the matrix is defined, is also incorrect. And so lastly, we can check BC. Matrix B is 4 times 3. Matrix C is 3 times 5. these numbers in the middle are both 3, that matches, so the matrix product is defined. And in this case, the dimensions are our outside numbers, which is 4 by 5, and therefore statement 3 is correct. It's defined and its dimensions will be 4 by 5. Statement 3 was the only correct statement. Next, we're going to move on to question 6, and here we actually have to do some matrix multiplication. Once more, pause the video if you want to have a go at this yourself, and then we will go through the answers. Okay, so how did it go? The first thing we want to think about is if this matrix product is defined or not. So once again, we think about the rows and columns we have. Our first matrix is a 2 by 5. Our second matrix is a 5 by 1. Again, the 5's in the middle match, so this matrix product is defined, and the size we're going to get out is going to be a 2 by 1. And that's really, really useful because we know then that we're only going to get either answer choice B or answer choice C. Answer choice D is the wrong size, and that is not going to work. And then we notice that the second row of B and C are the same. They both have 84. And so the only thing we need to think about is that first number, that 50 or the 30. That's the only difference between B and C. And this is often how ACT questions work. You don't have to do all of the matrix multiplication, every row or every column. You only need to figure out which answers are different, or only to figure out one of the particular numbers to figure out if you have the right answer. So let's do that top row. And so what we want to think about is we need to put a ring around that first row in the first matrix, 2, 4, 1, 3, 5. And then obviously put a ring around this column in the second matrix, the 1, 2, 3, 4, 5. And we're going to multiply those numbers together as we go along and down. So 2 times 1 is 2, 4 times 2 is 8, 1 times 3 is 3, 3 times 4 is 12, 5 times 5 is 25. Once we add all of those together, we would get 50. So 50 is the number we need at the top of our matrix, and therefore answer B has to be the right answer. Okay, so lastly, let's look at 2 questions where we have to work out the determinant of 2 by 2 matrices. Again, pause the video, have a go at these yourself, and then we will go through the answers. Okay, great. So question 7, this is just a simple question. We need to work out the determinant. We go from top left to bottom right. We do 9 times 3, which gives us 27. And then we go top right to bottom left, so we subtract 10 times 4, which is 40. So 27 minus 40 is minus 13. Last question, again, we have a bit of algebra, but it's not going to be too tricky. We're going to think about 8 times x minus 6 times x. So that gives us 8x minus 6x. And we know that this equals 18. So we can kind of think about this equation, 2x equals 18. And so x is going to equal 9. And we're done. If any of those questions didn't make sense or we're going through it too quickly, go back, have a look at them again and see if it makes sense the second time around. And otherwise, good job if that all went well. And that should be all you need to know about matrices for the ACT. Okay, so how did they go? If they went well, you're probably basically ready to tackle any matrix question the ACT is likely to throw at you. So get delving into those practice tests, find them and see how they go. If you're still having a bit of trouble, you might want to rewatch these videos or to try and do some other work on matrices. Otherwise, you can also get in touch with me for help. I also do provide one-to-one lessons, either in person in London or in Glasgow, or online over Skype, so I can help you wherever in the world you are. So if you're still having problems with matrices or with any aspect of the SAT and the ACT and you want some one-on-one lessons, my website address is below down here. Please do get in touch. I'm happy to help you in any way I can, wherever in the world you are. Please obviously do like and subscribe to the channel. I'm going to be putting more videos online about the SAT and ACT and hopefully going to cover the whole syllabus and everything you need to know. However, if you have any particular individual questions or any topics you'd like me to cover sooner or to cover in more depth, please do ask and I will try and facilitate that request as soon as I can. Okay? Thank you for watching. Again, please like and subscribe and I'll hopefully see and hear from you soon. Bye-bye for now.